This is section 3.1, basic identities. I'm going to admit this is going to be a little bit different, slightly challenging. Let's go ahead and move on to the next slide. Here's the reciprocal identities. We're going to be adding a few more. This is basically what you saw in section 1.4. And you should be able to see how this is related to this other reciprocal identity, and so forth. They're pretty easy to generate. A little bit of manipulating the equation or doing a little bit of algebra. The next set of identities are the quotient identities. I'm going to highlight this one. And you should be able, this follows from what I'm going to show you. I can describe tangent of alpha as y over x, as you learn in chapter 1. And then sine of alpha over cosine of alpha, I can do the same thing. Sine of alpha is x over r, cosine of alpha is x. Sine of alpha is y over r, cosine of alpha is x over r. And then I have this expression that looks a little bit funny. So what I'm going to do is I'm going to clean this up. I am going to multiply top and bottom by r over x. And notice that all of this here becomes 1. The r's cancel out and I have y over x. And this simplifies to, since these two are equal, then tangent of alpha is equal to this quotient. And again, this follows. The next one that I want to highlight is, it comes from section 1.6. This is the fundamental trigonometric identity, or the Pythagorean identity. How do we generate this identity? From this identity, all we're going to do is I am going to divide everything by sine of alpha to generate this other identity. Excuse me, sine square of alpha. So this is what I get. And notice that this becomes 1. This becomes cotangent, which is what you see here. And this becomes cosecant square alpha. I keep forgetting the square. But anyway, this becomes 1 plus cotangent square of alpha equals cosecant square of alpha. And I'm using 1 over sine of alpha is equal to cosecant square of alpha. And I can square both sides, and you should be able to see that that is the same thing. I can clarify that in class if you'd like me to. And let's go to the next one. So how do we generate this one? So all I'm going to do, now I'm going to make this into a 1. So I'm going to divide everything by cosine square of alpha. And this becomes tangent square of alpha plus this becomes 1. You see a 1 here equals 1 over secant square of alpha. Because 1 over cosine of alpha is equal to secant square of alpha. And if you square both sides, you end up with basically the same thing, which is what I'm using here. Let's go on to the next slide. So here's number 1. It says use the identities to find the exact values at the t for the remaining 5 trigonometric functions. So you're given secant of t as that ratio, and t is in quadrant 2. Since I'm going to have to find the other 5, I need to make sure that I know the sign. And this is what we learned in chapter 1. Sine and cosecant are positive, the remaining are negative. So to find tangent, this is what I'm going to do. I'm going to use this identity that you saw on the previous slide. So I am going to substitute for secant t, negative 4 radical 5 divided by 5. This is what I get. I am going to apply a little bit of arithmetic here. I'm going to square this radical that you see here. And then I'm going to end up with 16 over 5. And then I'm going to move this 1 to the other side. And that's why you see it here. And tangent square t is by itself on the left-hand side. A little bit of pre-algebra here. Common denominator, multiply top and bottom by 5. And you end up with tangent t squared equals 11 over 5. I'm looking for tangent, not tangent squared t. Take the square root of both sides. And again, tangent is negative on the second quadrant. and then I basically rationalize, and I'm not showing those steps. You should feel comfortable doing that on your own, and I end up with this. Now that I know tangent of t, I'm going to use the reciprocal identities to find cotangent. So I take the reciprocal of this, and then rationalize, and this is what you get. From here, I should be able to find cosine, since I know secant, using the reciprocal identities. So I take the reciprocal of this, that's what I get. I rationalize, which basically multiply top and bottom by radical 5, and then you should be able to see that once you simplify, you end up with negative radical 5 over 4. In class, if you want me to go over those steps, just let me know. So now I have, and again, cosine is negative on the second quadrant, so now I need to find sine. To find sine, I'm going to use this identity from the previous slide, or chapter 1. I am going to substitute cosine, which is here. Then I'm going to square this, move this to the other side, and I end up with the following. Common denominator, so I need to multiply this by 16 top and bottom, and you should be able to see that I get 11 over 16. Take the square root. I end up with the following once I simplify, and again sine is positive on the second quadrant, so that's why you see this. To find cosecant, I just need to take the reciprocal of this, and this is what I get as my final answer. So there you have it. Here are the remaining 5. In class, I'm going to show you how you can do this problem a little bit differently. Next slide. So here's number 2. This one's going to be a little bit different. It says write each expression in terms of sines and or cosines and then simplify. So you're looking at eventually everything needs to be sine and cosine. So first thing we're going to do, we're just going to manipulate this rational expression and express it the following way. Notice that if I was to multiply this rational expression times this one, I get the original. And then I'm going to take into account the reciprocal identities. And I know the tangent of t is equal to 1 over cotangent of t. And you should be able to see that I can just square, and then I'm good. So from here, I can rewrite the following on this part. Now this one, I am going to apply the reciprocal identity again for cosecant of t is equal to 1 over secant of t. And again, I can square both sides. And this is what I get once I substitute. From here, you should be able to see that I have cosine, This is not, so I want sine and cosine. This is not sine and cosine, but I can rewrite tangent using the reciprocal, the quotient identities the following way. And I can square both sides, and I end up with the following. From here, you should be able to see that this is going to cancel out. And I end up with sine squared t plus cosine squared t, which is equal to 1. And I'm using the Pythagorean identity from an earlier slide and also from section 1.6. This is the end of number 2. So here's number 11. It says use the identities to simplify the expression. So what I'm going to do, if I look at the numerator, I notice that there's a common factor of sine square of theta. So this is what I get once I factor it out. And again, just a little review. If you were to multiply this times this binomial, you end up with the original binomial. And then from here, I am going to be applying the Pythagorean identity. But what I'm going to do is I'm going to rearrange this so it'll look like this. So I'm going to solve for, I'm going to do the following. I'm going to move this 1 to the other side, so it becomes minus 1, and I'm going to move this cosine square of theta to the other side, and it becomes this. So now that I know that this is equal to negative cosine square of theta, I am going to substitute it here. So then I have the following. And then from here, I'm going to rearrange this as a product, not as a division. So I end up with the following. And again, this is the same thing as that once you multiply. And then from here, I'm going to use the quotient identity, and I know that 1 over secant of theta is equal to cosine of theta. And then I end up, once I substitute, I get this. And then I'm just going to clean this up. And notice that at the end, it's going to be a negative answer. And then use my rules of exponents. And this is the answer to number 11. Now we're going to be jumping to number 13. So here's number 13, same directions. What I'm going to do is I am going to first apply what we did on number 3. I'm going to give each of these, I'm going to give this binomial its own denominator. So I end up with this. And notice that this is going to become 1. And then I'm going to rewrite this as a product instead of a division. And then from here, I'm going to apply the reciprocal identity for both of these. Here's the secant. Here's the cotangent is equal to 1 over tangent. So I make the appropriate substitutions. I end up with the following. Again, 1 over cosine square of t. This becomes cotangent square of t. Then I'm going to rewrite this in terms of cosine and sine, using the quotient identity. This is what I get. And notice that at this point, the cosine squares of t are going to cancel out. And I'm left with 1 minus 1 over sine square of t. And then from here, what I'm going to do is I'm going to, again, use a reciprocal identity, which is this one. And this is what I get. Now, I don't stop here. Why? Because I'm telling you not to stop here. Not only that, if you were to stop here and you were to check in the back of the book, they wouldn't have this as the final answer. And eventually you have a pretty good idea when to stop and when not to stop. Trust me on that. Let's continue. And then at this point, I need to continue, like I said. I know that cosecant square of t is equal to 1 plus cotangent square of t, which this is coming from the extension to the Pythagorean identities, the Pythagorean identity. We can derive this from the Pythagorean identity. So I'm going to substitute, instead of cosecant square t, I'm going to substitute this. And I end up with the following. And notice that once I distribute 1 minus cotangent square t, these go away, and you end up with negative cotangent square t, and this is your final answer. We are going to skip number 14, and there you have it.